Hello everyone. As Alfonsina said, I'm going to just briefly present the Atom framework developed under our institute. So I'm a researcher at the institute. I'm mostly focused on research and development on real-time 3D, so including also immersive VR and also presentation on web. So including 3D and also WebXR presentation that we are going to see some examples in a few seconds. So first of all, today there is we have the possibility to create very complex and interactive 3D presentations on the web. So here we are looking at an example on Sketchfab platform. So basically, you have a web page, and without any installation of nothing required, you can see all these models with also complex materials and so on. So just using your browser. And another, on the other hand, we have also a tighter integration of our browser with our devices. So that means that a web application can access your microphone, your camera, GPS, and also presenting for immersive VR and AR device, so headsets and so on, given, of course, user consent. So for cultural heritage, that means that we can think about web application that basically does not need any installation for the final user or the final visitor of our museum, our archaeological site, like for instance, for the Vani case, of course. There are no app stores involved, and we have also a possibility to have to consume all these experiences and 3D presentation on different devices. So all these ingredients translate into a great opportunity for museums, institutions, laboratories, researchers, and so on. So we as Institute offer an open source solution I already mentioned in previous presentations that is called Atom. So Atom allows you to create a liquid web application. That means that they are can be accessible through a wide range of devices, starting from mobiles, smartphone, tablets, up to PC, museum kiosks, up to headsets, so immersive VR and also immersive AR. It's very easily customizable and also can be deployed in several ways that we'll see at the end of the presentation. And it's based on web standards. So for example, one of these standards for 3D presentation and 3D assets is the GLTF, that is an open standard. It is soon becoming also an ISO standard, widely adopted. And as you can see from the video, it is crucial for us because it offers a very robust definition of materials. So that means that once we create and publish these assets, they react consistently to lighting settings and environments, virtual environment that we are going to create. It's something that is also very easy to produce in terms of course, content creation for 2D modelers and so on. It's extensible, but also is very interoperable. That means that these assets are interoperable today and tomorrow with other platforms that are already there, like the Sketchfab platform that we already seen, and also others like Smithsonian Open Access Collections and so on. Here are some examples of the same identical assets presented by completely different technologies. Sketchfab in this case, Smithsonian Voyager, and Atom Framework. Here you can see other other examples of interactive presentation, in this case with golden materials. So as you can see, there is also, they react very well also to the environment. So you have a more immersive 3D presentation, a more advanced way to present materials. Then there is another standard that we can use for more larger data sets. In this case, we can imagine massive point clouds, massive photogrammetry dataset. The format is called 3D Type, developed by Cesium, that is already embraced by the industry, and also it's also can be created also with other software tools very easily. And this can be, of course, useful for more larger, of course, a massive data set that you want to interactively consume. So moving on, if we talk about basic exploration and ways to move around and inspect 3D items in Atom, you can see from the video that you have different modes. So there is first person, there is more orbit modes, and also device orientation modes to explore in different ways 3D objects and 3D scenes, also including, as you can see, immersive VR devices, and also including viewpoints. So you can actually annotate viewpoints on your objects, and you can also constrain navigation in certain points, certain location of your environment, and so on. So you have full flexibility in these terms. Then, as basic tools, we have also basic semantic annotations. Of course, as you can see here, we are creating semantic annotation on top of very easily creating this annotation on top of these 3D items that you can associate with multimedia content, as you can see from the video. Then, of course, as you can see here, using another device to create these annotations. Then we can, of course, access other tools like measurements. Then we have also the possibility to, for immersive VR, to have this advanced interface that, of course, are more targeting immersive VR headset, immersive AR headsets, and so on. And then on top of that, of course, we have sharing options with QR codes and so on. So it's actually very easy to access and create these tools with just a simple browser without any sort of installation. Of course, what we are looking here was all these tools were driven by the community and user feedback, also gathered through European, so international, but also national projects that are helping to evolve the framework and improve all these functionalities. Then on top of that, you can also imagine the creation of online galleries, so 3D collection of items with included already built-in search and filtering capabilities. So for instance, you can search by author, by term, but in this case, for instance, you are searching by material, so you can filter out items on different, using different policies. So as you can imagine, all these basic tools are there, but of course we all have different requirements. So that means that we can imagine different profiles, different lenses to access the same identical 3D assets, 3D model, 3D object, and also scene. So this is why in Atom, there is the possibility to create custom presentation, custom web applications. Like in this case, we are looking at the video, applied games, or you can create a custom interaction model. Like in this case, we are looking at the temporal lensing approach that allows you to discover a different layer. In this case, it's temporal, but it can be anything else. Or create advanced semantic tools for experts, for professional researchers, and so on. Or even creating tools that allow experts to analyze how users are interacting with our objects and our scenes. So in this case, we are talking about visual or immersive analytics tools. And you can, of course, imagine your own lens to inspect and explore all these 3D assets and 3D scenes. As already said, you can see from the official website, there are other examples of national and international projects that are built on top of the framework. So and lastly, in the last part of the presentation, we can see how we can actually deploy our experience. So how to deliver to the final users both the 3D content, but also the application. So here you can see three basic scenarios. There are examples, of course, starting from the very basic one with the sort of with the museum kiosk, for instance, with offline solution. You don't need any internet connection. Then, as we grow, we have a middle scenario where you have something that is with users coming nearby, some hotspot, for instance, and they can access together the 3D content or the web application experience. Or we can grow to the worldwide scenario where you have content and also the application that can be physically very, very far away from you. So in the case of Vani, of course, we have what we have seen up to now. We have several options. Of course, one is to have like a local museum kiosks. So you don't, in this case, we don't need any sort of internet connection or local connection. You could just use the kiosk, and there is the presentation of 2D models, but also environments. Then we have a second possibility with the local network, for instance, inside the museum, where visitors using their own devices can access 3D content. Then we can imagine something that is maybe on the archaeological site, so that can be accessed to online or local hotspot on the archaeological site. And of course, the fully online solution, so something that can be accessed very far away from another location of the world, for instance. So the last three can also be offered, but for instance, using QR codes. So that just remember, we don't need any installation. So users can just use QR code, and from the QR code, you have full and direct access to the interactive application or the interactive 3D experience. So it's very flexible, and of course we have all these options to that we can exploit for the Vani Museum. So that's the end of my presentation. So if you have questions, just let me know.